client who has something that's not on the list. And so what I typically do is do a literature review and see what I can find out. And I want to tell you that sometimes the only work out there was done on another continent. All right, so I'm going to show you some really diverse data today. All right. I also hear the horror stories, so I'm going to weave in a few horror stories as we go along today of times when people have applied something and it hasn't worked out well at all. Okay, so that's where we're going. Okay, so over the years, no matter what waste product is out there in the universe, if it contains a nutrient, someone thinks, oh, put it on ag land, you know? And we've had some real failures with that. Anybody here remember fly ash? All right, that was one of our failures, okay? And if it's basically a liquid, a water, who knows what else it has in it, but sure, irrigate that crop, all right? We can get into trouble with both of these if we don't become aware of the fact that there's some downsides to some of these. Now, the reality is we don't test for those downsides routinely, but I think there are categories of materials that you need to be very suspicious of and want more information about before you're willing to include them in a nutrient management plan or recommend that someone put them on cropland or even residential land. All right, so I want you to know that even the things we normally include in plans could potentially have some issues that we're concerned about. So can you think about anything else that might be in manure other than nutrients that you might have a concern about or your clients might have a concern about?
Organisms like salmonella.
Yes, microbes, particularly pathogenic microbes. Okay, anything else?
Heavy metals.
Heavy metals, yeah. And I will say that there was a lot of work done years ago on swine manure, because there's apparently a lot of copper in swine manure. But some studies show that, yeah, there might be a lot in the soil, but the plant doesn't appear to take up a lot. Because, you know, a lot of those micronutrients, you get too much and you can get a toxicity. But the work pretty much showed that that wasn't a problem. But that whole food safety thing about using manure on crops eaten raw, that's all about pathogens, all right? Okay, so I'm going to talk about these because we use animal manures, and you probably realize that a lot of animals are treated with either antibiotics or compounds called ionophores. Now, from what I can tell, an ionophore is nothing more than an antibiotic that's used only for animal production, okay? So, routinely used in many animal types. Lots of different families of antibiotics and ionophores. Many of them pass through the animal unmetabolized. So they come out in the urine or the feces in the same form as they were ingested, all right? They could impact soil organisms, and I can't recall a paper offhand where that's been looked at. But the issue with us is plants may take some of these things up. So do plants take up antibiotics or ionophores? Now, if you took your plant phys in your biology when I did, or in soil fertility, they said, oh, don't worry. Plants only take up little organic or ionic stuff. They don't take up organics at all. And then we knew, oh, well, they must take up some because we have systemic herbicides and pesticides. But, you know, don't worry about it. It's only these little tiny things, okay? Well, we know that that was a gross oversimplification. Not so much that. I'm not criticizing the people who taught us what they taught us. We've got better ways to measure now. We can go down to lower levels than we could ever do before. We've got some equipment in university laboratories that they never had 30, 40, 50 years ago. So we can study things at a level that we could not study then. Okay, now I want to just do a little risk assessment 101. There might be something that you're concerned about, let's say an antibiotic in the manure, but is there exposure to the population you're concerned about? And we're usually concerned about humans. If there's no exposure, there's no problem, all right? If there's exposure, but there's no risk, there's no problem. So if there's something in the manure, even if it gets into the food, if what gets into the food isn't a problem for humans, it's no problem. Now, you may not agree with this risk assessment paradigm, but this happens to be what our regulatory agencies use in the United States. Not what's used in Europe, but what's used in the United States. So let's look at this. Until I think I did this webinar about 5 years ago. It was called Non-Nutritive Aspects of Manure. And it's the first time I really learned about this whole idea of an average daily intake. It's the first time I heard that there were maximum residue levels allowed in food. Okay? They actually set levels of the maximum amount of an antibiotic that can be in meat and you still sell it. All right? And the organization that does this is called JECFA. It's a bunch of people, World Health Organization and UNFAO. It stands for the Joint Expert Committee on Food Additives. So they look not only at antibiotics, but a whole bunch of other things that are used in the food system. And they're the group that has set up both the average daily intake levels and the maximum residue levels. And those maximum residue levels are only set for animal products. There wasn't any recognition that there might be an issue in plant products, right? Because it's the animals that are getting medicated, so look at them. So if it's an antibiotic, they look at it has to be less than the amount that would trigger an allergic reaction in a sensitive person. So if it's a sulfa drug, it's below the level that would cause someone like me to have an allergic reaction, okay? If it's something that's chronic, it's the amount that could be ingested over your lifetime with no health risks. Kind of like the MCL in water. You know, you can drink 2 liters of water a day for 70 years and you won't get cancer. That's what the MCL is based on, okay? So it's very similar to that. Okay, so Holly Dolliver at University of Minnesota in the Department of Horticulture published this about 11 years ago and has done a phenomenal work since if you're interested in this. But she looked at swine manure on 3 crops, parts of which are eaten by humans, corn, lettuce, and potato, okay? She did this in the greenhouse. She grew these things for 45 days, but she got potatoes because she talks about analyzing the potatoes, okay? And she actually found that lettuce, and she looked at 2 levels. I guess they dosed the pigs with 2 levels, I don't know. That lettuce took up more than potatoes, and potatoes took up more than corn. That sometimes the dose makes a difference, you know, and sometimes it really doesn't, okay? So she absolutely proved that plants can take up this molecule, this sulfamethazine, a sulfa drug, all right? Since then, they've done field work, they've looked at biosolids. If you're interested in knowing more about this, search for Dolliver, University of Minnesota, because it's absolutely phenomenal work. So the question is this a problem? We know people eat it, so I would say that's exposure, right? But is there a problem, all right? Well, what they did was look at the maximum amount that would be allowed in animal products was 0.1 milligrams per kilograms of fresh weight. And the fact is that the 3 vegetables average 0.05 milligrams per kilogram. So from that point of view, it would look, okay, if this were an animal product, it would be allowed, okay? And then they looked at how much was allowed, this average daily intake. And it turns out that you can take up 5 milligrams per kilogram of body weight and still not have a problem with an allergic reaction. Great. So then they went through this little scenario where they said, well, this is someone that has a heavily vegetable-based diet. How much would they take up? And what they found was that the amount that would be taken up was way less than the average daily intake. So there was an issue, antibiotics from treating an animal. There was exposure, okay, got into the plant. People are going to eat those plants, but there was no risk. All right. Okay, do you have any concerns about compost? Okay, what are your concerns about compost? Chuck, what are your concerns?
Well, we know certain herbicides do not compost out.
That's right, some don't. Any other problems?
Yeah, if it isn't completely composted, you get some organic or hard chips in there that are going to tie up nitrogen.
Yes, you can have a mobilization. Okay, good. So we're going to talk about both of those. Carbon-nitrogen ratio is really important. So here's some data on some compost. The first 3 of these are actually products that are sold. They're commercial products sold to people, all right? Now, the magic carbon to nitrogen ratio number has always been kind of thrown around cavalierly. It depends upon what book you read and what source you look at. I've seen it as high as 30 to 1. I've seen it as low as 20 to 1. There's a lot of 25s to 1. Just depends upon who you're reading, all right? But at some point, the carbon-nitrogen ratio is an indicator to us that we're probably going to get a mobilization, or maybe we'll have null net gain, okay? And below that point, we should get some release of nitrogen. So 2 of these studies were done by Greg Evangelos and the guys down in Virginia. They looked at Huck's hen blend, which is mostly yard waste with some hen manure, and they looked at panorama pay dirt. which has more litter than it has yard waste. And we've got the CNs, so you might expect there to be some immobilization here, because 29 is pretty high. You would expect some mineralization here. And then there's a couple from Vermont. Fred Magdoff did these a number of years ago. FertLife, which is supposedly a composted cow manure. And then he looked at 3 composts that were produced by organic farmers on their farm. So they were mixtures of manures and various other crop residues and stuff that were produced on the farm. So the FertLife is 50 to 51 CN. So someone showed me that analysis. I go, whoops, maybe a soil conditioner, but don't plan on getting any nitrogen out of this stuff. And certainly, the same thing with the higher CN for one of these composts, although they varied. On farm, made according to the operator, they varied from 16 to 25. And when you look at the mineralization rate, the year of application, Hux-Henblin did virtually nothing in terms of supplying nitrogen. That is so small, you'd have to have it in a research situation in a greenhouse to even be able to detect it. This is like no nitrogen released. Now, it didn't immobilize any nitrogen, and that kind of surprised me because 29 is pretty high. All right? The 18, you'd expect some release, and sure enough, this is a 5% mineralization rate. This is expressed as a decimal fraction, and that's what we assume for a well-composted material right now in Maryland. If someone were to call me or to look at our information, that's what they'd see. All right. FertLife actually immobilized a little bit. It actually took up some nitrogen from the soil, all right? And obviously, some of these small-scale composts did the same. So if you've got clients that are making batches of compost on their small farm, I would suggest you encourage them strongly to get that stuff analyzed. It's true that one of these was less than 16 and it's still immobilized, but I'd still get it analyzed so I had an indicator, okay? So that CN ratio is important to look at, but it's a wishy-washy number in the sense that that carbon can come from a variety of sources and they're not all going to behave the same. So it's a very crude first cut indicator. Okay, now, manure can contain active ingredients from the herbicides used on the crops that were grown to feed the animals. And the real bad guy here is this family, the pyridine carboxylic acid family. So it's things like chlorpyrrolid, picloram, chloroxypyr, and trichlorpyr. Things like Stinger, Reclaim, Forefront, and Milestone, and this has a really bad rep. They were introduced in the late 90s. They were for broadleaf weed control, particularly for very problematic broadleaf weeds like thistle, okay? They are not metabolized by the animal that consumes it, all right? They go right through, all right? They are also, we have data now to show, they're not altered by the composting, all right? They cause severe deformation, stunning, and for all practical purposes, the death of the plants, okay? I got introduced to this bad guy, I think it was about 2007 or 8. I got a call from the master gardener in Harford County. They'd put in demonstration gardens at one of the stadiums up in Harford County that Cal Ripken funded, right? And she says, our plants aren't growing well. I think there's something wrong with the soil. And I said, well, did you get a soil test done? Yeah, well, send it to me. Well, the soil was fine. Well, it was July. I'd already gotten the annual reports in. I thought, oh, what the hell, I'll drive up there. So I did. And I looked at this stuff, and these plants were tiny, and they were all gnarly. So I took a couple back and showed it to a friend of mine. And she, that's herbicide damage. It turns out that they had used a heavy, heavy rate of a horse manure that they had gotten from someone they knew. Where do we usually get our stuff, right? From someone we know. And they got it from the bottom of the pile because they thought that would be the stuff that was the most decomposed. So this stuff was like 50% compost, okay? Okay, I also want you to know that when this stuff was first marketed, it was allowed on lawns, all right? So a number of cities, I think up to 5, but I only know the name of one, actually had their publicly funded city or county yard waste composting facility go bankrupt because they were composting grass with leaves, and when they sold the compost to the end users, there was such damage to the plants that people wouldn't buy it anymore, okay? The product is now no longer labeled for lawn. Thank you, Chuck, for confirming that. Matt Norris, too. Thank you. You guys are great when I need to know about herbicides, okay? So they're no longer labeled for lawn care, but they are labeled for pasture land and for hayland. So they're still used by people that are raising animals on pasture and need some weed control for these problematic weeds, and they are used on hayland. Okay? Dow AgriScience has this, now has a one-page fact sheet. It's beautifully done. You need to look at it. Grasses grown for hay may not be exported outside the United States if you use this stuff. Manure and urine from animals consuming it may contain enough to cause serious damage to sensitive broadleaf plants. Do not use hay or straw from these areas treated with this or manure from these animals in compost. All right? There are 9 more things fleshing this out in case you don't understand what this means. So they have general information, they have a nice little graphic, and then they spell it out for you. Okay? I suggest you look at it. It's a good teaching piece. It goes from general rules to specific rules to a beautiful diagram. Someone did a good job of designing this. Fact is, we could have animal manures out there with this, and we have people composting it, and we have people putting it on their grass. And I have to tell you that about 6 months ago, from Harford County again, I got a call from someone that says, we want to start a centralized horse composting facility for the people that raise horses. And I said, whoa, you need to talk to the master gardener, because there's a story behind this, and I wouldn't recommend doing this unless you know what everybody's using on your source material, okay? And just last week, I talked to someone who says another county in Maryland is considering this. Unless you can be sure that this product is not being used on those fields and fed the animals you're getting manure from, I wouldn't touch composting horse manure or cattle manure for that reason, for that matter, okay? So let's not walk into this one blind. We've got the data that says it's a huge problem. I do want to say that Spokane, Washington was one of the cities whose composting facility went bankrupt after losing its client base due to contamination with this. And they and a number of other cities got together for a class action suit. I believe the United States Composting Council helped them with all that. Anyway, Dow Chemical did settle with these cities. Seattle estimated that their damage in terms of site prep, equipment, et cetera, was $4 million. What do you suppose the settlement was? $23,000. Yeah. Okay, so lawn clippings as an end source. I'm talking about this because those chemicals are no longer labeled for lawns. I hope when people aren't using them on lawns anymore. But I got 3 calls this last year about organic growers, particularly small organic growers, that viewed lawn clippings as a good nitrogen source. Well, okay, let's look at it and see. Okay, so New Jersey was concerned about running out of landfill space a good 20 years ago, and they now have a ban on lawn, like branches and stuff like that. But they also don't like the grass, because grass, you know, have you ever opened a bag of grass on Monday morning that you picked up at the side of the road and it's been in the 95-degree heat all weekend? It smells bad. So they had problems with odor at the composting facilities, and they'll take only a small amount of it, from what I understand. But anyway, they did some work in 2001, because I think their ban started in 1998. They looked at a whole bunch of organic wastes. They looked at 2 soils, a sassafras, which is very close to what we have a sassafras here, and an adelphia. I'm not sure what that's closest to here. They looked at 2 rates of nitrogen, 100 pounds of total N and 200 pounds of total N, and they did this in a growth chamber for 25 weeks. And the carbon-nitrogen ratio in the grass was 18. Now that surprised me. I thought it would be lower. This is lush grass clippings. I would have thought it would have been less than 10, but whatever, it was 18 in theirs. They actually found mineralization rates that range from 30%, 0.30 as a decimal fraction, in a sandy clay loam, or 0.65, 65% in a sandy loam. So we see this a lot. There's a higher mineralization rate in a coarser soil with more macropore space and better oxygen flow than there is in heavier soils. We see this particular trend over and over and over. If someone looks at more than one soil for a mineralization study, they're going to find a higher rate in a coarser textured soil than they do in a finer textured soil. But at least now we've got some data to help plan development for someone who uses this as a nutrient source. And we'll be updating our information with this over the next month or so. Okay, spent coffee grounds. Man, is that big. I got 4 calls this year on that, all right? So I didn't realize, I'm thinking, if Starbucks has had this problem, this program of giving coffee grounds away since 1995. Why am I only hearing about it in 2018? Anyway, it's the first I'd heard about it. I knew people who took coffee grounds, but I had never, I didn't know that Starbucks was actually giving them away and encouraging them to be put on gardens. So do you think there's any concerns with using coffee grounds? If you had to think about it. Coffee grounds. We use it to make a drink. It's a food product. Any potential problems here?
pH.
pH, yeah, anything else? Caffeine. And it turns out caffeine is only one of the phenolics in it. There's a whole family of phenolics in it, okay? So what do high levels of phenolics do to the soil creatures? Do we know? Well, we're beginning to learn, okay? So again, I'll go back to that study that Rogers did at Rutgers. And I'm going to call these SCGs, spent coffee grounds. They found that the coffee grounds they used in their study had a CN of 32, so we'd suspect immobilization. And in fact, they found it. It went from not too much to pretty substantial. This is tying up a lot of the nitrogen in your soil, okay? But they didn't do any other measurements other than looking at the release of nitrate and ammonium. So you know how they do when you find something. Oh, it could be this, it could be that, and they just throw out ideas. But there's no data collected to know what's really going on. So it turns out that I also have this in my files. This is a study done at the University of Granada in Spain. Coffee's drunk all over the world, in case you don't know. Tea's big, but coffee's bigger. Coffee is the second most traded commodity in the world after oil. Okay? There's a lot of coffee grounds out there. They looked at two rates, 2.5% of the soil and 10% of the soil. These are humongous rates. They also looked at two soils. Now, this was a fairly semi-arid area. So one was alkaline and one was close to 7. They did the work in a growth chamber. They didn't look at nitrogen release at all, but they looked at, could I see any microbes, and is there any evidence that the microbes are growing in this organic material? So they did scanning electron micrographs at the end of the experiment, and they could see fungal growth all over the place. The fungi don't care about what's in this stuff, all right? They're growing. And they looked at carbon dioxide evolution. Okay, carbon dioxide is the end product of decomposition. So it's a crude measurement of how much biological activity is going on. Crude, because there could be changes that are just changed from one compound to the other. But if it goes all the way to the end, it's CO2, all right? So this is complete decomposition. And what they found was there was way more in the low rate and even more in the high rate. So are coffee grounds suppressing microbial growth overall? No. Stuff's getting broken down at a higher rate. There's more decomposition. There's more carbon dioxide being given off, okay? And the fungus don't care. They're growing, all right? Then a bunch of guys in Japan looked at this. And this was published in a journal I didn't know about until then, Plants Production Science. They did a field experiment, and they did it for 2 years with 2 crop cycles every year. So summer, fall, summer, fall. And they looked at a sandy clay loam that had a pH of 5.4. Didn't give us a whole lot of information about the soil. They looked at 2 rates, essentially 4.5 and 45 tons of coffee grounds per acre. The 4.5 is closer to what an agronomic rate would be. 45 is outrageous, okay? But here's what they found in the first year, all right? First of all, they looked at 5 different crops that first summer. So they basically put the coffee grounds on here. Alfalfa, guinea grass, crotalaria, sorghum, and sunflower. And you can see there's suppression here. Even at the low rate, the alfalfa does worse, the guinea grass does worse, crotalaria doesn't care. Sorghum does worse, sunflower does worse. The high rate, ooh, not good at all. But again, that is way beyond an agronomic rate. Then they planted cool season crops in the fall, and you can see, hey, oats did pretty good at the low rate, barley didn't, rye did. So what's this telling us? You better have more than one plant in your experiment because they don't all respond the same, all right? Then they carried it into the next year, okay? So they put the coffee grounds on here. This is the first year. Now we'll look at the second year. Look at this. Now even that high, even that high rate is causing a growth similar to the control. Guinea grass is going crazy. Crotalaria, sorghum better, sunflower better. So the second year around, even these high rates are now supplying nutrients that these crops can grow better. And again, the second fall, not too much difference between the 3 rates in any of these, okay? So there's a couple lessons here. Look at more than one season, okay? Because the New Jersey thing said, hey, this stuff's bad. Well, it was bad the first year on that crop, but it wasn't bad for everything, and it's good the second year. Now, I don't know who would want to use it under those circumstances. You know, usually if you have ag land, you want to grow something this year. But the fact is, if someone, let's say, maybe they had fallow land, maybe they were taking stuff out of production for a while, there might be some cases where people actually can put in, you know, a cover crop they're not harvesting and use this as a nutrient source. But don't expect things the first year, because that's risky. Okay, now I want to talk, we doing okay for time? Okay, irrigation water. There's an effort in the country right now, and University of Maryland is part of that. Conserve, have you heard about Conserve? Use alternative water sources. Okay, that's great. But some of the water that might be seen as tiding us over in periods of low rainfall could have some things that we don't want in them. Like, can anybody think of anything? I can think of 2.
Like those ducks.
Yeah, like E. coli and other pathogens, yeah. And in case you've never been to one, this is a wastewater treatment plant. Can you think of anything in wastewater treatment plant effluent that you might not want on your crops or in your food? Oh, okay, and we're going to talk about one, okay? Okay, so there's a lot of characteristics that might guide us in using these things correctly. They're not routinely looked at to use something in a nutrient management plan. Now, all of those things could have nutrients in, so you're probably going to have an analysis of them. But have you ever seen a COD or BOD done on a manure? Well, no, it's not done on it. It's done on wastewater. But it's a measure of labile, or readily oxidizable carbon, all right? So if you have someone that wants to use whey on their land, that would be a good way to tell you how rich it is in carbon compounds. High labile carbon is going to tie up your nitrogen, okay? And there's an anecdotal story in the old literature, and this is the 60s, which is old even for me, all right, that showed, anecdotally, now they didn't measure a darn thing, they describe a fungal mat forming on the soil after whey was applied, and that rainfall ran off that soil until that fungal mat spent its life and died. Okay, so you can actually clog up your soil with organic biomass. There's also suspended solids. There's a case where someone put on an irrigation water that was very high in clays that actually appeared to clog the soil's pores. So suspended solids are something you need to be concerned about. This would look cloudy when you looked at this water in a glass. Salts, obviously, you know. High acidic or high alkaline waters, pharmaceuticals, pathogens, okay? You had a client that had problems with hops, right, when they put brewery waste on? Oh, yeah. All right, but we don't know why, because we don't have a sample of that stuff. I think it was salt shock, personally, yeah. But who knows? Maybe the next time we can get a hold of some of this stuff and do a big scan on it.
I had a client years ago that used mushroom compost in his fields before he planted his trees, and was getting, sometimes it was fine and sometimes it was funky, and I had him test it.
Oh, high in salts.
It was
yeah.
crazy.
Yeah, they can be high in salts. So there's some wonderful work done by a soil chemist who's at a university in Israel, and he looked at an anticonvulsive drug. So we've got treated wastewater being used on vegetables. He looked at lettuce, tomatoes, and wheat. He also looked at biosolids. Okay, so this is by Shevitz, Benny Shevitz, and a bunch of folks at the Hebrew University of Jerusalem. And this is an issue for many people across the world. In Israel, it's a semi-arid climate. They use 85% of their wastewater effluent on crops. Okay, but in California, we use 46%, and we get a lot of our fruits and vegetables from California. So this is just as much an issue for us as it is for them. All right, he looked at carbamazepine. I'm going to call it CBZ. It's an antilepic drug, and it's fairly resistant to breakdown, so he thought it would remain intact long enough for him to study it. And he looked at 2 soils and 3 crops, potatoes, lettuce, and wheat. And he looked at both biosolids and wastewater effluent, but there was way more put on in the effluent because it was put on all season long, as opposed to the biosolids were put on a little before the growth started. And I'm just going to show you lettuce. This is the two different soils, the Near Oz and the Saad. Very little was taken up by the biosolids, but in the lettuce there was a significant amount on both soils, and there was not only the parent product, but the breakdown product and the secondary breakdown product. When we look at complex organic molecules, we can't just look at what we started with. The work in the hazardous chemicals like the chlorinated hydrocarbons shows that the breakdown products need to be looked at too to understand the full story, and sometimes they're worse than what you started with, okay? Vinyl chloride is way more toxic to humans than the PCE that your dry cleaner dumped out the back door for years, okay? And it's the third or fourth byproduct down the line. All right, so yes, it's taken up, okay? He also did some wonderful work to find out, well, where is it in the lettuce, okay? So first he looked at the center of the lettuce head and the part around that, and then the outer leaves. His thought was, well, they're taking this up the entire season from the irrigation water. Is there more in the parts of the plant that need more water so they don't dry out in this dry climate? And his hypothesis was there may be more in the outer leaves than in the core. And sure enough, there was, okay? There was way more in the external leaves than in the core. Let me see, the core is here, okay? And again, not only the parent product, but two of the breakdown products are there. So overall, there was way more in the outer leaves of lettuce, okay? We think there's way more vitamins there too, but there could be more other stuff there, all right? And less in the central. Okay, down here, he also looked at outer leaves alone. So is there more, let's get to this. Is there more at the outer fringe or in that inner part? And sure enough, he found that there's more in this outer part that's more exposed to the wind and the sun and must be moving more water into that tissue to keep from drying out, okay? So the tissues that are more exposed to the sun and the wind are going to have more of this chemical than the parts that are more protected. So this scientist, Benny Chavez, was actually invited into the University of Maryland by the School of Public Health, and he did a very interesting seminar a couple of months ago. So this information isn't published yet, but this is what I got from listening to him at that time. I thought it was pretty clear from finding these chemicals in the food that there was human exposure, but he went ahead and did another experiment involving humans. And he had two experimental groups, people whose vegetables were irrigated with wastewater that contained this drug, and people who ate their vegetables that had only been irrigated with fresh water. And sure enough, he found elevated levels of this drug in the people whose veggies were from wastewater irrigated water, okay? He also found that once they went off that and started eating freshwater irrigated crops again, that their levels returned to baseline. So the question you might want to ask yourself is, well, is this bad? Is there a risk? We know they're exposed. They ate it, it went through their body. Who knows what it did? I don't know. Well, unfortunately, there's no decision support system for drugs in humans, okay? So I hope he's taking this to the next level and having pharmacologists and neurologists or whatever who know how this drug works in humans. I hope they can work and figure out, is this bad or not? Is this a problem? All right? And this is just one of a host of things that are given in wastewater. If you haven't seen the reconnaissance studies of what we have in our wastewater and what we have in streams downstream from our wastewater, I would be glad to send you those studies. It is astounding. Okay? It's everything from caffeine and aspirin breakdown products to a whole host of drugs to sunscreens. You know, if we take it in or we put it on our skin and we're on a sewage treatment system, it ends up in the water if it's soluble. And there's a lot. And there have been several excellent studies on that. Okay, what about bacteria? Do plants take up non-native bacteria from the soil? Do they take up bacteria? Do they internalize bacteria if they are spray irrigated? Now, this work, the work I'm going to talk about, was done at USDA in Beltsville. It was done on soils from the Virginia Eastern Shore used for tomato production. And the driver here is the fact that tomatoes have been labeled as the cause of several outbreaks of disease, salmonella in humans, okay? So it was phenomenal. This was so interesting to read because I don't do microbiological work, and it was interesting to see how they can isolate things. So they actually did a series of experiments. They introduced bacteria below the soil surface. They used the term inject, but they don't say how far below the surface they did it. They put some on the blossoms themselves, and they put some on the leaves. And then they isolated bacteria on all these surfaces, in the soil, on the plant, on the fruit, and in the fruit. If you want a copy of any of these things, let me know. I'd be glad to send it to you. It is great Saturday night reading, okay? So what they found was different serovars respond differently. They looked at a cocktail of 5 different serovars. Now, I didn't even know what a serovar was. A serovar is like the cultivar in a fruit, okay? Macintosh, Fiji, okay? All same genus species. They also found that if the bacteria were introduced when the fruit was blooming, it was inside the fruit. They found that when they inoculated the soil at the end of the growing period, they could find the bacteria on the leaves endophytically and within the stems, okay? So it kind of points out to us that all these efforts for post-harvest cleanliness may not be enough, okay? We got to think about what we're doing while the plant is growing in the field. So I'm not saying hand washing and toilets and all the stuff in the packing house isn't needed. It clearly is. But this points out that we may need to actually look at what's happening pre-harvest if we're concerned about contamination. Okay. Does anybody have any questions?
We're going to go off food.
No. How'd I do for time?
You did great.
Oh, good. Okay. Any questions? Now, there's a lot of other things I could have looked at, but I figured, don't overwhelm you. Yeah, Charles.
So this opens up a whole new window
Oh, it sure does.
with food safety
Yeah.
because of how we're using water, what we're storing water in. There was a case in Carroll County probably 20 years ago where the dairy farm downstream from the Westminster wastewater treatment plant, and the cows had a higher level of somatic cell count, higher somatic cell count.
Yeah.
And there was a settlement of some type done on that.
Wow.
Because they found that, this was an early stage where they found out that the wastewater treatment plant was putting out more stuff than they thought it was. But this is now getting.
And then the cows were drinking the water.
Because
Yeah.
they were drinking it right out of the stream at
Sure,
that point.
sure. Oh, they still are. They still are in Howard County.
I see nothing.
I do, every day.
But this is a whole nother, for strawberries.
Oh, absolutely.
We're doing frost irrigation on strawberries, and we're pumping it very often from a pond.
But doesn't the Food Safety Modernization Act now require that you test water?
Down into some of the constituents that we, in small enough counts. I mean, we can get down to parts per billion now.
Oh, are we talking about bacteria, or are we talking about chemicals?
Well, either
Either
one.
one. I mean, these farm ponds, some of them are, they're down at the bottom of a field or pasture. I mean, all kinds of stuff.
Okay, well, don't go off the deep end here, because what we don't know is that whole risk thing, all right?
Yeah.
I think it's pretty clear. We could have exposure of some chemicals from the manure, from the irrigation water. Absolutely, no question about it. The whole belief that I was taught when I was in grad school, that plants don't take these things up, isn't true. Now that we can measure smaller amounts, we know that plants can take some of these things up. That's a pretty sizable molecule, that anticonvulsive drug, okay? That had a 5-side with 2 6-sides and a little arm off it. That's a pretty big molecule, okay? That's not an ammonium or a nitrate, all right? So it's clear that plants can take things up. The question is it a risk? If it's not a risk, it's not a problem. So the risk management arm of the science needs to talk to the ag side of the science, and work like Shevitz and Holly Dolliver need to be examined by the human health people to see whether or not there's a problem. I'm not saying there's a problem. I'm just saying there's exposure. Okay? We need to re-examine some of our old ideas and say, it's not a problem, forget it, don't worry about it. We need to re-examine that idea. We need to know that plants take some of these things up, but the next step is there a risk? And remember that some of these levels are in parts per billion, or even high parts per trillion, right? They're not high. But how high is too high for some of these compounds? We do know that with endocrine disruptors, it appears that very low levels whack out aquatic organisms. So you can say, oh, well, it's only parts per trillion, it's not a problem. And then you've got intersex fish, where you've got a population that's 90% female and 90% male. Well, it may be in parts per trillion, but it's clearly having a biological impact, okay? But we don't have indicators like that for humans.
Aren't they starting to get with the pharmaceuticals, the animal health pharmaceuticals and the human pharmaceuticals, it carries over into meat, and there's some concern about resistance down the road for using these meds in human? I think that's a big deal.
Well, and see, I don't see where that JEFCO limits address that. They address how much can we have in the meat product before it causes an allergic reaction. They haven't looked at how much in our diet can we have and still not have resistant bacteria
I think that's
develop. And if we're taking them in, what's it doing to our microbiome? That if you're doing any reading, is very important. We've got a skin microbiome and a mouth microbiome and a gut microbiome, and they all talk to one another. And you whack one out and you're going to have problems with everybody. So if we're taking in low levels of these things, is that a problem for our microbiome? These are complicated issues, and we don't have all the answers yet. Yes?
Part of the food safety issue is the fact that I think the food and drug have done a terrible job of educating the public that they need to wash their food. And yes, we have to do all these things in the packing shed and in the field. I mean, there's no question whatsoever. But a generation ago, they washed everything. My mother, my grandmother, out of their own gardens, washed everything with soap and water in the sink. My mother owned a Tasty Freeze for 36 years. She washed bananas with soap and water and put them in a bowl before anybody peeled them.
No, that's a great idea, because you're going to touch those bananas.
I'm telling you,
Wow.
we're not doing that anymore.
No.
When was the last time you washed a banana? And let alone apples, lettuce,
Well, I'll
everything.
tell you, after the cantaloupe
Crushed
outbreak,
everything.
a few years ago was that.
And
I spread cantaloupes now
Oh,
with
yeah.
vegetable brush.
They wash everything, even if it came out of their own garden.
Wow.
And Food and Drug is consistently points the finger at agriculture, when in truth they need to do a better job
Public health education.
of
But aren't there,
educating the public.
but there are some things that you can't wash off. I
That's
remember
true, and
another
some
talking
work
game.
done at a conference I went to
There's
about
not
15
much.
years ago
Yeah.
showed that washing didn't get things that had already been
Soap and
absorbed
water.
onto a biofilm, so
Right.
I still, after I went to that
majority
talk,
of
I
it
still
you get
wash things, but I know it's not necessarily going to get everything off of it.
But it gets
Oh,
99%.
absolutely, yeah, absolutely.
It's
Yeah.
rare to not wash it off.
Yeah.
You wash with soap and water. I don't know anybody that washes it.
Oh, no, I don't know anybody who washes it, so, yeah.
Trish, you mentioned that the American risk assessment is very straightforward, different than the European assessment.
Yeah,
You know, the European model's different.
they use something called so I think you have to prove it for, you'll have to look into that, but it's called a precautionary principle. Yeah. But there's lots of gnashing going back and forth between the two ends. Ours is definitely less than the European one. Okay, so again, in terms of the carbon, nitrogen, and all that, analyze it, okay? If it's above 20, be careful, okay? If it's below 20, you might be okay. And again, you might not, all right? But we can test for that. In terms of using all kinds of water, look at some things. If you're getting something unusual, like a potato chip plant waste, that's going to be high in COD and BOD. It probably needs to be diluted before you put it on the soil. Or you're going to have a microbial mat, or you're going to have phosphorus, or you're going to have you're going to have nitrogen tie-up. So just start to think about more than total nitrogen, ammonium, phosphate, potash, moisture, okay? Sometimes there's other things we need to spend the money on to look at. And all of those things are going to cost more money. Don't kid yourself. Just getting seed and costs more money. Okay, they've already done the end, but if you want them to do the seed, they're going to get you another 10 or 15 bucks. Okay, but I think it's information worth having. And in terms of these other things, realize that they're there. Continue to read, continue to listen. The science on this is rapidly evolving. It's not the same impact on every crop that's out there. The good thing is it tends to be, when people have looked at the leaves of the fruit, it tends to be less in the fruit of the plant than in the leaves of the plant. Got to watch the roots, though. This can be a problem. Right? So all I'm saying is, science is marching on. You need to march on in your information base, too. Okay? It was quite a shock for me to learn plants take up organic farms.